So I'm going to hand it over to Carolyn Soper-James in just a moment. She's going to be talking about APIs and OOUX and how they are like peanut butter and jelly. So she'll have about 30 or so minutes of a talk. Then we'll have plenty of time for Q&A. And then we'll do a quick breakout room just so y'all can kind of get together and discuss, meet each other. If you want to drop off. But sometimes the most beautiful part of this meetup is actually hanging out for the breakout room and actually talking about what you learned. So I do encourage you to stay, but I know everybody has got tight schedules. So without further ado, Carolyn, oh my goodness, what do I even say? She is the Director of User Experience at Acumium, which is just a wonderful agency that is basically completely embodied object-oriented UX, is using it with most, if not all of their clients. We just had a really great podcast conversation all about how she's using object-oriented UX with her clients and seeing so much success with that. So she is a certified object-oriented UX strategist from cohort 1. Cohort 1 is always so near and dear to my heart. People that jumped on to this certification before it was proven at all, before there were any testimonials. So I'm always just so grateful for that, and so grateful for Carolyn and everything she's doing to help evangelize object-oriented UX and teach object-oriented UX through her own genius lens. So I'm going to hand it over to Carolyn.
All right. Thanks, Sophia. Is my audio still good? Can you hear me?
Audio sounds wonderful.
All right, good deal. So let me get this presentation going. Thanks everybody for taking part of your day to join us for this. Let's see. Oh, starting screen share will stop another computer sound share. Sure. Okay.
I always do that.
I'm kicking Bob Marley off. I feel bad. Bob Marley's a legend, but
yeah.
All right. Are we seeing the title slide?
Yes, you look
Yay.
great.
All right, good deal. Let's get going. So this is a presentation that it's a slightly modified version of a presentation I gave last week, Tuesday, at that conference, which is a developer-centric conference, tech conference up in the Wisconsin Dells. So between last Tuesday and today, I've been trying to modify it and shorten it. So I'm going to try to go kind of quickly, hopefully not too fast. But yeah, today we are here to talk about OOUX and API design and how they really are very well suited to each other. And OOUX can be a very strong foundation for good API design. So get started here. So Sophia did a really nice intro to me. I won't add too much to it. As she said, I'm Director of UX at Acumium. The one thing I will mention is that my path to UX is a little bit non-conventional. I actually came to user experience from server-side development. So that is not necessarily, I think, a normal path, but what it has done is it's given me a lot of ability to work with developers and a lot of empathy for what developers go through, kind of a unique perspective on the work that we do as UXers, or if we've got some developers in the meetup, which I hope we do, you know, to be a good ally with devs and get good stuff done. I am part of the first cohort. I'm certificate 15, which I wear proudly because I think it's a number that Sophia likes. So yeah, just thrilled to be part of this community. All right, so I'm going to try to toe the line here because I think we do have sort of a mixed audience of people who are a little bit more design heavy and maybe a little bit more development heavy, and maybe some people who are more business focused. So I'm going to try to go through some stuff here, but not belabor anything. You're not going to get a deep dive into APIs. You're not going to get a deep dive into OOUX, but hopefully you'll get enough of both to have a good handle on why we think there's a good connection here. So I'll start off with the API side. So what is an API? API stands for Application Programming Interface. It is basically software on a server that allows access to the features or data of an operating system or application. It enables the sending of information back and forth between a site or an application and a user, and it does it in kind of a black box sort of way. So APIs use a request and response cycle. So a user makes a request to a web server to get something or to do something, and the web server returns the result as a response. This kind of request response thing is similar to what happens when we request web pages from a server, but the response, rather than being HTML, CSS, JavaScript, is in a raw format, very often something like JSON. So kind of the quintessential example of APIs, a metaphor for that is a waiter in a restaurant. So in a restaurant, the waiter serves as the API between the customer or the client and the kitchen, which is the back end. So a diner at a restaurant can make an order to the kitchen that goes through the waiter. They don't have to know anything about how the kitchen does what it does. And in many cases, some places you probably don't want to know how the kitchen does what it does. And likewise, the kitchen just gets an order for some meal. It doesn't have to know anything about the diners, but the waiter is the go-between, the server is the go-between to get that order to the kitchen and then the food back to the diner. So that example really illustrates how APIs facilitate the separation of concerns. And APIs are everywhere. There are APIs in our computers, in our smartphones, in operating systems, gaming consoles, even some refrigerators. The focus we're going to have today, and kind of some of the most common APIs these days, are web APIs, which you interact with using HTTP. APIs are a key user interface for developers. So this is just the start of many parallels that I found between user experience design and API development work through the course of researching this talk. Okay, so what makes a good API? So a good API is simple and memorable. Some APIs will just expose the backend database structure, which is extremely overwhelming and not very usable. A good API is actually a highly designed thing, and it follows kind of the maxim of when in doubt, leave it out. A good API is going to be gentle with newbies, and it's going to be rich and empowering for people that have more experience. The memorable piece of it is really saying that if a developer uses an API call in one context, that developer should be able to come back and use it again without having to check the documentation and remember, how do I use this again? And if a developer works with an API call regularly, they should be able to quickly memorize the resources and associated operations for that call. They're also difficult to misuse, and that really means that the implementation and integration is very straightforward. It makes it less likely that a developer is going to write incorrect code, provides informative feedback and really robust error handling, and it's not going to enforce strict guidelines on how developers can use it. They also use appropriate terminology, and appropriate terminology is really plain terminology, simple, human readable, descriptive. Rather than user, harkening back to a project that Sophia and I talked about recently on that podcast, rather than user, we would say for a music festival application, we have students, we have teachers, we have adjudicators. So it uses human readable terminology and descriptive terminology. Most importantly, though, is that it solves the right problems and it knows its real user. So what does this mean? It means that before there's any coding done, the developers really started off by understanding who is using this API. Why would people want to use it? What should it let people accomplish? Very often when we think of somebody consuming an API, we might think of a developer writing code, but they're not doing this for their health. And whether they realize it or not, the developer that's doing that, writing that code, is doing it on behalf of people who will eventually use the software that exposes the value that the API is offering. So a good API not only considers the developer experience and offers the streamlined implementation and the complete, accurate, and easy to digest documentation, but it's also going to consider the common use cases and users that the end users will have, which is going to make it easier for the developers using that API to build useful things quickly and efficiently. And if we think about it, that really sounds like some of the considerations that we have when we're designing user experiences as well as designers. So business value of APIs. This is an API is a product basically, and there's huge business value to be gained from good API design. So an API can commoditize access to kind of a single source of truth for information. It offers an access to consistent information, which can lead to assist with operational efficiency and help reduce errors. It also allows developers to really focus on what they do best. So an example here would be that rather than having to write code for things like stock prices or an inventory of national parks or properly formatted mailing addresses or weather forecasts, just kind of like similar to how most bakers don't want to have to spend the time milling flour when they need to make a cake. APIs allow developers to focus on adding core business value and let those other sources provide that more commodity information. There is also huge commercialization or productization opportunity with APIs. People subscribe to APIs, developers subscribe to APIs, and they pay really good money for them. APIs can be a whole business model. So as a product, an API is actually a brand ambassador too. So it better be useful and it better be usable and it better be worth the money that people are paying for it if it's a for pay thing. A good API also expands the reach of the organization and can open up opportunities for third-party development. While I was researching this talk, I saw a specific mention of, Reddit and Spotify are two good examples of this. So they have very, very intentionally opened up their APIs to make their data available to their users and open it up for building interesting applications. So when a third-party developer can use an API, they can create products that are somehow reliant on the business that's at the other end of the API. And if they do that, they have the potential to create repeat customers for the business that's hosting the API. So for example, with Spotify, if a third-party developer created an application to explore new artists that uses Spotify data, as people use that third-party app to find those new artists, they're more likely to continue or start using Spotify. So it's a good business proposition for companies like Spotify to invest in a good, usable, robust API. So what goes into planning a good API? So the first thing is taking the time to actually plan. This can often get rushed through in the excitement to generate code, but you wouldn't build a house with a blueprint. So likewise, doing API development without some upfront planning is a poor idea as well. The planning, good planning involves end user research, and this is not just understanding which API client developers are going to be using the API. It's also having some understanding of the eventual end users for whom the API is enabling this experience. So getting to understand that can be done in any number of ways. It can be done with existing user research. It can be done with personas, empathy maps. I read that some organizations use jobs to be done. The idea here is that looking for ways that in a non-technical and easy to understand fashion to understand who those end users are. The end users can also be both internal to the organization and external. So if it's internal, your end users could be people like customer service or product development or marketing. If it's external users, it may be those API client developers who are using the API. And so now we want to understand what problems do they have that we could potentially solve with this API. But it could also be end users of the software that's exposing the data or functionality that our API enables. And so we need to understand what are those common use cases that those end users need accommodated. Good planning is going to require an inventory of user functionality. And this doesn't mean that we start with planning API methods. It doesn't mean that we're focusing on the get, post, put, delete kind of things. This is really more the what problems are we solving? And we're stating what is it that these people need to do? Are we going to, with the API, are they going to need to create a user, edit a user, reset a password? Are they going to need to do things like viewing a profile, adding new items to inventory, getting a list of products, maybe that are filtered by different criteria? So it's understanding what are those practical needs that come in for people that are going to use this API. And then lastly, before we get into coding, ideally, there's some sketching or diagramming that's involved. So that might be anything from doodles on a whiteboard to actually creating some deliverable type diagrams like an ERD, data flow diagram, business capability model, or a domain model. Or, as we're going to talk about here in a little bit, potentially an OOUX object model. And this is also some of the planning considerations are also very akin to what we consider in user experience design. So the buddying up between API design concerns and user experience design concerns is pretty tight. So all that leads me to make the strongly held contention that API design is user experience design. I'm certainly not the first person to suggest that. I saw references to it elsewhere, but I strongly agree. There's certainly more to it, but at least in part, API design 100% is user experience design. And so to come at it from a similar mindset as people who are doing user experience design for end user interfaces, there's a lot of benefit to be gained there. So that's why, I feel like OOUX, it's not just a front end design methodology, even though that's, I think, originally what it was conceived as when Sophia developed it. It really has a ton to offer to development, and it can help developers plan and design and build better APIs and just better systems as a whole. So now we'll shift over to the other, the quick start guide to what is OOUX for the people on the meetup who maybe aren't as familiar with OOUX. So OOU, and I feel really weird talking through this with Sophia on the call because this is her baby, but we'll see what grade she gives me when I'm done. So OOUX is it's a design methodology, and it helps us align software that we build to a user's real world mental model of concrete and defined objects. I have found that it's an absolute power tool, and that's because humans think in objects. We understand everything around us, the world around us, whether that's physically or digitally, by understanding the objects. When we use something that's digital, ideally the object should be clear. Like we should hit a website and all of a sudden it's like, oh, that's a that thing and that's a that thing. But it doesn't always happen. So, the physical world, there are conventions, there's consistency there that we can count on. A table generally looks like a table. A chair generally looks like a chair. We don't often get ketchup bottles that look like hairspray bottles or baby bathtubs that look like wheelbarrows. There's conventions in the physical world that help us navigate through it. And it helps us navigate through the physical world easily, safely, and ideally happily. But that's not true in the digital world because we don't have some of those physical constraints. It's kind of the Wild West. We can end up building absolutely obtuse things that make zero sense to users. So with OOUX, we define a system of what's, the what's that are the real world things. So that could be products, tutorials, recipes, events, parks, pets, any number of things. And then how they interrelate with each other before we jump into the hows of interactivity, like registering or searching or checking out. So developers who do object-oriented programming, they've been doing this for a really long time, but this is often not how designers work. It's not really how designers were taught. They've learned to think procedurally, designing actions before truly understanding what's getting acted upon. There's an article that Sophia wrote that referred to a similar example here, where if we say, well, we need to design, Johnny cooked. It's like, well, how do we know what to do if we don't know what Johnny's cooking? Is Johnny cooking pasta? Is Johnny cooking an evil plan? Is Johnny cooking meth? The way that we're going to design that is going to really depend on what it is that Johnny's cooking. So before we as designers can create things like, or design things like create a new recipe, we need to understand what is a recipe, what makes up a recipe. So this methodology ends up simplifying and decluttering our designs and really streamlining development. We ultimately end up with far fewer things to build. And there's this really rich web of relationships between these objects. And all of these objects are distinct. And from the development standpoint, this is important language, loosely, if at all, coupled. So that makes them much more independent and easy to kind of put into the configurations that we need them to be in without there being dependencies there. So from a development standpoint, one of the most powerful things about OOUX is that all of the work we do in OOUX is directly usable by developers. And that's because we are immediately speaking something much closer to the same language. We're working from a foundation of common understanding. And I can speak from experience in saying that it is a rock solid foundation that is immediately going to accelerate any digital project that you're working on with devs. So why do we design in objects? There's benefits here both for the end user customer and then also for internal teams. So from the end user perspective, it allows us to match our users' mental models by having these clearly defined objects in this real world domain. Our system has a sense of instant familiarity. It allows us to flatten learning curves and provide immediately logical and highly usable experiences. So our brains evolved around these physical objects. And so when we enter any system that can quickly answer for us, what are the objects that are here? Where are they? How do they relate to me? How do they relate to each other? And then how do I interact with them in this environment? That system is immediately going to be more successful. Contextual navigation. So contextual navigation is a term for, it's that thing that happens when you're scanning through a web page and you see something that's sort of tangentially interesting. It might be completely unrelated to the thing that you were looking at 50 milliseconds ago, but you decide you want to go and learn more about that. You should be able to click on it, and that's contextual navigation. Contextual navigation helps users get to content through content, rather than depending on the top nav. And I can't remember the name of the person who said this I can't think of it, but there's a person who said that the top nav is the fire escape. It really should be the place you go where you want to make sort of a complete change in where you are. But that natural sort of movement through a system should be done through the contextual navigation. It also increases usability by matching how the users talk about things, matching their terminology, and giving objects the distinct, consistent, and recognizable shapes in our system. From an internal perspective, I've found that the internal benefits can equal, if not outstrip, the external benefits, and that's kind of a strong statement, but I stand by it. The internal benefits, we get a shared language on our team, making the team communication easier and a lot more effective. From a structure standpoint, it lets us explore and document the really deep structure of a system and how the objects within that system interact with each other. So we get a really strong foundation of information and a much more comprehensive view to allow us to make decisions. It enforces simplicity as we define and refine and prioritize our objects. That helps us reduce noise and complexity that can often come from extraneous design elements, or I would contend API methods. It also helps our system scale and increases maintainability. When we have a system that's based on objects, we are free to iterate. We can add new concepts, we can add new functionality, and then we don't have to worry as much, if at all, about regressions because of the highly componentized way that we've thought about the system. It enables better SEO through this really strong set of structured content and all of this valuable cross-linking. And then the portability. So these independent and loosely coupled objects drastically increase the portability of the system, which allows developers to build better APIs. So OOUX is the methodology, and ORCA is the process that Sophia's developed. Again, I feel really weird talking through these slides, but so ORCA stands for Objects, Relationships, Capabilities, or CTAs, and Attributes. And with this process, before we design a single screen, we are identifying what are the objects that are in the user's mental model, what are their relationships to each other, what capabilities or calls to action do these objects offer to users, and then what are the attributes that make up the objects. If you do it tip to tail, it's a 15-step process. There's 4 rounds that go through discovery, requirements, prioritization, and representation. Representation being the last thing we do, and that's where the screen design actually comes in. But one of the things I love so much about OOUX and the ORCA process is that literally no matter how much of it you do, it's going to add value. So you don't have to do the tip to tail process. It can be 25% of it. It can be 15% of it, and it's going to add value. So for those who aren't as familiar with OOUX, we'll go through this real quick, the pieces of ORCA. So the objects, with the objects, we're finding objects through noun foraging. We use whatever we have available here. It could be a project brief. It could be existing system documentation. It could be an RFP, a slide deck, a whiteboard image of scribbles. It could be somebody's cocktail napkin where they've, jotted down some ideas. And then we identify, with all those nouns that we're looking at, what are the things in the problem domain that might need representation in the system? We don't pick out all of the nouns. We're looking for things that offer some sort of value to the user or to the business. And we use this acronym of SIP. So we identify which of these things have structure, instances, and purpose. We're not looking at modeling singletons. We're not looking at modeling things that don't have really value. So we do an initial sort of assessment of do they have structure, do they have instances, and do they have purpose? When we're doing this work, we're starting off with a brain dump, literally like what can we think of that kind of fits this criteria, but we go into prioritization later. There are parallels. I'm not an expert on domain-driven design, but I believe there are strong parallels with this work and what happens in domain-driven design. So for the developers in the room, that may be a meaningful correlation to you. When we do this modeling, so color coding is a very key part of doing this work. So when we do this modeling, we're using blue for the object map, and that might be a physical sticky on a whiteboard. It might be a label on a Trello card, as we'll see in just a second, but we keep our objects in blue. Relationships. So what we start off by saying, how might these objects that we've identified relate to each other? Once we have a set of those candidate objects, we're identifying how, what are all the potential ways that they could depend on each other or relate to each other. This is also highly exploratory and a complete brain dump to start. And the reason for that is that we might come into this with preconceived notions about the relationships that exist between objects, but by allowing ourselves to explore, there can be really valuable relationships that just hadn't surfaced yet. And this is a really great opportunity to reveal those and maybe add value that we didn't even know was there. In this work, we also indicate cardinality. So what's the scope of the relationship between these two things? Is it 0 to 1? Is it an optional but a limit of 1? Is it an exactly 1? Is it 0 to many, or is it 1 to many? So we start to define how many of these relationships might exist between two of these things. For the developers, this is an extremely strong foundation for data modeling or ERD development. And relationships we also reflect as blue on the object map because they are using those objects and just showing how they relate to each other. For the capabilities or CTAs, here we're looking at how might people or the system need to interact with these objects in order to make useful stuff happen and help solve problems. This is really where we're dropping pins for potential interactivity later. It allows us also to start to identify where we might need to access or update information. And this can be the beginning of API integration planning. We've also found that this can help significantly with user story creation because it is directly tied to interactivity, which usually is directly tied to things that end up in a development queue. And we map these items in green on the object map. And then for attributes, there's two kinds of attributes. So the first one is core content, and core content is data that belongs solely to the instance of an object. While some of this data might be shared between instances, it's not dependably shared, and any commonalities between two instances are really going to be kind of outliers. So these would be things like name or email or identification or ID number, phone number, description, featured image, that kind of thing. And those we reflect as yellow on the object map. The other kind of attribute is metadata. So metadata is data that is potentially shared and instance agnostic. This is stuff that could potentially describe multiple object instances. These are things that could be used for sorting or filtering. So examples would be color, category, status, difficulty, expiration date. Think of those left-hand bars where you see all those filter criteria. Those would be metadata kinds of things in our map. Metadata can also shift into or out of being an object. So sometimes we will initially start off and think that we have an object relationship, and then we'll decide through prioritization that actually we don't need to represent this as an object. We're going to kind of, I don't want to say demote, but we're gonna demote it to a metadata. We're gonna take this out of being an object for right now. We're just going to have this be metadata. That can be done for release planning purposes, prioritization purposes, or just because it really doesn't warrant being an object. Likewise, we might start off thinking something is metadata, and as we talk more about it, we realize, you know what, this is a full-on object, and so we promote it from metadata to an object. Metadata we reflect with pink on the object map. All right, so how does OOUX translate to API design? So as I was looking at, I'm not an expert in APIs, but as I was looking at APIs, I found there are some really strong correlations between the things that we're mapping in OOUX and the things that are present in an API structure. So in OOUX, we have the object that we just talked about. In API design, we have a model. And for those devs who know about API design, I might not be using the terms you use. Bear with me. I appreciate your patience. Hopefully the general idea is solid. In OUX, we have the relationship. In the API design, that could be a reference, saying that within this model, we're containing a reference to another model. In OUX, we have the capability or CTA. In API design, we would have the operation or the method. And then lastly, in OUX, we have the attribute. And in API design, we have a property. So with that, let's go look quick at an object map. I'm going to stop sharing that, and I'm going to share my browser real fast. And I'm running tight on time. I told you guys this was an hour-long presentation. I'm trying to squeeze in here.
You are all good. We don't have time for a breakout room. We want to make sure we have time for Q&A, but you're all good. Don't rush.
Yeah. All right. Okay, so hopefully you're all seeing the browser screen. So this is an example. I work at an agency, so for client confidentiality, purposes, I can't share an actual client example. But this is the object map that I actually put together during my certification process. So Sophia will remember the Tempest Players Company, I'm sure. So what I wanted to show here, both for people who aren't familiar with OOUX or haven't seen object maps, this is how one can look. Because I was cohort 1, I know there's some different ways of doing things now in object mapping that I haven't quite caught up with. I'm sort of, this works for me, so I still do it. But what I wanted to show here, I'm not going to go through the full structure of this, but what I did want to show is how we might start to reflect API concerns in an object map. This is one thing that, along with just this process of untangling the complexity and mapping the problem domain, is tremendously useful for developers who are building APIs. We can also start to use some of the deliverables of OOUX in order to continue to jumpstart the work that happens with API planning and design. So to give you an example, if we look at some of these things, we might be able to start saying, what's the type? If we're going to have this attribute in our API, what type is this? Is this going to be an int64, an int32? Is it a string? Is it a datetime string? Is it an enum, bool, file, etc.? So that would be one thing that we could potentially start doing in the object map is reflecting actually what type of data might this be in our API. Another thing that we can do is start to, for the CTAs, the capabilities, we can start to reflect things like, for example, maybe we just start to put a pin in that this is a post. We're going to need to have some sort of a post operation in our API to accommodate this adding of a review. Or here on this add a note one, another different way that we could do this would be, it's probably easier to just look this way, is to just start to list out, roughly, this would be a post, and we might call this method or this path season/note, where we're saying for the season object, if we want to add a note, that's potentially what that route would look like. And then lastly, maybe we look at adding a whole new kind of card to object maps, potentially, where we're calling out the API operations that need to get created. Granted, we don't want the object map to turn into this huge, noisy, difficult to use thing, but maybe there's potential to start to let developers get in and start calling out, we're going to need a get here, and we're going to call it season, /productions or something like that. To get productions in this season, for example. So some options there. And then the last thing is, we've been talking about sort of developing APIs, but also when we're doing this object mapping work, in many cases, there's going to be data that we might be sourcing from external APIs. And so the object map is a really great place for us to start to, again, drop pins on, I think we're going to need to get this from an API. So as we're doing this work, and especially, I didn't explicitly say this, but this means that developers should be involved in this process. They should be shoulder to shoulder with the designers doing this object mapping work, because it allows the devs to start thinking about, one, if we're going to build our own APIs, what might those need to do, or what might those need to look like to kind of reflect the structure and be clean and all that good stuff. But also, if there's data that we're sourcing from elsewhere, we can start to think about where might we need to get this from? What are the particular pieces of information that we need to source from an external API? And so that we could do just by dropping some sort of a label or a pin and call it from API or external API or whatever we want to call it. But the idea is that the object map can maybe start to do a little bit of the lifting to help developers kickstart their work. The other things I want to show just really quick here for those who don't have a lot of context for the OOUX deliverables and how they might relate to development deliverables. So this is an example of what we call a core object relationship diagram. This happens pretty early in the process, but this is where we're taking all these candidate objects. These are the, this was my certification diagram. So these are the same objects that we saw on the object map. But all we're doing here really is identifying all the potential relationships and the cardinality between those objects. And so if you look at this and you consider a developer being part of this work and helping to contribute to this, the next thing that they might be thinking about doing is an ERD or developing a data design. And if we go to an ERD example, there's a pretty good jumpstart with the core object relationships to get this is not the ERD for that hypothetical system, but you get the idea that an ERD is reflecting a lot of the same stuff that we're already reflecting in the core object relationship diagram. Lastly, I wanted to show, and again, this is completely just a example. This is not reflective of the stuff you've seen beforehand, but I spun up an account on Swagger just to kind of show some of the structures of an API. So here we see that down here we've got the models, and if we look at a model for an order, for example, or over here maybe it's easier, we've got these attributes, and we can really easily see how the attributes from the object map could directly translate to helping developers build out these models in their APIs. Likewise, we've got things like let's see, what's a good example here. So, some of these operations that we need to do. So the post, the put, the get. Put is an update operation for those that aren't familiar with those. So adding a new pet to the store, updating an existing pet. These descriptions for these operations, if we look at the capabilities and how we describe those in the object map, those can be a really good start for how devs can start to build out these API structures. I'm trying to think if there was anything else that was really, the one thing I will note here, where's the example? So this one shows an enum of order status. So you could really easily see that coming from metadata values from our object map. And let's see if we look at, here's another example in the pet model, this category of pet. So, this maybe isn't the best example of this actual relationship, but this kind of a reference, this relationship between an object relation, a nested object relationship within an object is also something that the object map really starts to detail out. And I think that's all I have for that show and tell. So I'm going to stop that. I'm going to go back to the PowerPoint. I have just a couple more slides here. And share this. Okay. So we looked at the object map. So lastly, just a couple.
I still can't see your screen.
Oh, I'm sorry. I didn't click share.
There we go.
Zoom always gets me. Click the screen, and then you have to say share. All right, better? Good. Okay, so OOUX is really, I think of it as API rocket fuel, and we kind of talked through these things in the browser pieces, but that core object relationship diagram is really a simplified ERD. It's a very strong start to an ERD. The object map is also a really strong start. It's already going to start to outline the objects which can be the models in our API, the attributes, which can turn into properties, and the relationships, which can be our references. The metadata can provide sources for our enums. The CTAs and capabilities will show where interaction might go, which can help us stub out those API operations. And then just the object discovery in general can help us highlight places to source data from other APIs. So ideas here, and again, we kind of went through this in the show and tell there, but ways to do this, practical tips: add those API planning queues to the cards in the object map. We can highlight inbound data from another API. We can suggest field and property names, add examples of API modeled objects to the object guide. I didn't show that, but the object guide is another deliverable out of the process. And that model example that I showed in Swagger, we could actually put an example into our object guide to help build that out as a more useful reference for developers. And then we can also, I didn't show this either, but we could potentially add operation methods and potential paths to our CTA matrix, which is another OOUX deliverable, where we're kind of detailing out the who, what, where, when kind of information for those CTAs. We could also start to add some API planning there, like what kind of operation and what might the path for that operation be in the system. I had this in the talk from last week, and I kind of wanted to keep it here, even though I know we have a mixed audience today. So the thing I'm starting to really do is try to evangelize with devs. And the talk last week was so well received. I had like starry-eyed developers coming up to me afterwards. This resonates with devs. And it's not just for API design. So this is a really strong start for data modeling. It's a really strong start for content modeling. Lets devs do what they need to do in a more natural way. And it's a useful jumpstart to the work they have to do. It allows common understanding and vocabulary with designers and stakeholders. This is a huge one. It reduces the need for them to reverse engineer designs. When I asked the team, the people last week, how many of you have had to do this? There were all these hands that went up, and I said, how fun was that for you? And it was all this like head shaking. So this keeps devs from having to do that, or significantly reduces it at least. And then lastly, it provides just a really valuable way for developers to participate earlier on in projects. Devs have extremely valuable input to these projects, even projects that are considered to be design heavy. I always get a much better result when I involve my devs as early as possible, and they add stuff that would not come up if they weren't involved as early. And that's it. Thank you. I think we still have some time for Q&A. That took a little bit longer, but thank you so much.
Thank you so much, Carolyn.